So thank you all for coming. Thanks for all of the interesting talks we've had over the last few days. I've had a really interesting time here. I came into this last year without really any past APL experience. Actually, I realized that several years ago I actually did do one project in J, but for whatever reason it didn't stick with me, and so coming back to this, it was all fresh again. My personal background is that I'm a programming language enthusiast. When I was an undergraduate, I actually focused almost entirely on programming languages. But when I came to grad school, when I was forced to choose an advisor, I ended up taking a different route, and so now I'm in computational biology. But in the past, I used to just search out programming languages whose paradigms were different than I was used to, just for the sole purpose of learning to think about problems in a new way. And so when I heard about this contest, I was immediately interested in it. The announcement reached me through a professor in my department who I really didn't know, but when I checked it out, here we go. Oh, yeah, actually, forgot about the slides I actually put together. At the beginning of this, because I really didn't know anything, I never expected to end up writing something that looked like this, that seemed totally cryptic, but it actually being beautiful, meaningful, efficient, and I just think that's incredible. And later on, I'll actually put in some context what this means, although of course I don't expect you to learn what it is that I studied. But another thing that I never expected was to attend a talk where people would talk about the enclosed of a simple scalar, and at the end there would be applause. So in the beginning, I knew APL as that programming language from decades ago that had this gigantic keyboard with all kinds of symbols. But at the same time, I knew that although there have been many languages, and many of them have faded, ones I've played around with like Prolog or Forth, Snowball, that all have their interesting ways of thought, but they've all pretty much faded, that APL is actually still relatively vibrant. But even more significant than that was for me seeing someone like Ken Iverson, who for his work won a Turing Award, meant that there's something really meaningful there. There's something to gain. There's something that deserves an award of that magnitude. And the fact that there's a prize is like a cherry on top, to make it even better. So to start, I knew that there would be many people entering the contest. So I knew that what could I do to stand out? And there's this phrase that you can write Fortran in any language. That regardless of where you are, you can pretend like it's what you're familiar with and kind of cram the code that you're used to into it. So I wanted to know how to avoid this, and I wanted to know how to think like an APLer. Not just to win the contest, of course, but actually to gain something from the experience. And so from the very beginning, I thought, okay, online tutorials usually aren't good because someone did it in their free time and it's never complete. You always get past 1 + 2, and then they say, to be continued, under construction. So I thought, let me go find some books. So I searched my university library, and I found books from 76, 84, 89, and actually I took these out, and even some of the really old ones I even had to do interlibrary alone, but I still did my best. But I remember one of my favorite ones when I got to the end said, and in the next few years, APL2 should come out, and we'll have nested arrays. So I thought, I don't know if I'm going to win the contest with this. And so I was actually really surprised and delighted to find out that there was an entire book, like a professional quality book, available on the Dialog website, and that ended up being my main tutor for APL, because I didn't know anyone who was using it. And so my first impression, after going through all these chapters and learning all these primitives that you don't really know how they're going to fit together, and also there's just so many that when you try to write some code, you can't, and until you're comfortable with it, you think there's like 40 things to look at. When if you start in C or something, you're given nothing, so you have to go from scratch. But APL, you're always thinking, there's got to be a better way to do it. I could fit this in 2 characters, not 4, if I only knew, the one that's missing. So as I was working on the contest, I would be kind of rereading the same chapters and thinking, oh, I forgot about this one. I have to go back and fix this. I have to go back and fix that. Because things are difficult without all of them, and it's really hard to get all of them in your head. But all the time, this was one of the examples that was in the Mastering Dialog book, that when I saw this, they had this function they asked you, if you have two matrices and you want to interleave them so that the first column is from the first matrix, the second column is from the second matrix, the third column is back from the first matrix, how do you do this? The easy way is, to allocate a matrix at the beginning and say the first column, the second column, the third column. And then later on they give you a more elegant way where you have like the index assignment where you say columns 1, 3, 5, 7 are this one, columns 2, 4, 6, 8 are this one. But then later on when you learn about like the axis operator, I don't know, it's like profound in some way that I can't really put in words, that you can just stick them on in an extra dimension and then reshape it in your answers there. I don't know. And so I thought that was incredible. And that was the sort of thing I looked to imitate when I was trying to write code. Although, of course, I didn't really reach that, but the judges were fooled. So as I was doing this, I ran into several pitfalls. And the first one is actually interesting because there's an article in the Vector that was handed out here by Roger, where he says, what we always claim is the most beautiful function in APL is actually doesn't give you the answer you want. And I actually ran into multiple times in different contexts the fact that what I thought was a scalar wasn't, and I would get dimension or mismatch or range mismatch. I don't even remember which errors which. All I know is that I got a lot of them. And the other thing was enclosing and disclosing. I got confused often when I needed it or not. Like I remember one of my core functions later on, I start out with a list of scalars, and then I run a function on that with each. And each of those returns like a matrix so that it's boxed. And then I reduce that so that there's just one thing at the end, and I'm just really confused that ends up being boxed too, because I guess reduce has to return a scalar. And so there's all these things like this that keep coming out. And one of the things I agree with Mstislav is that I miss types when it comes to APL. I'd like to write something, and the compiler will tell me, this will return an answer. Maybe it won't be the right answer, but at least I know that the compiler will accept it. And the other thing I ran into, since in one of the problems that Mstislav explained, we had this model for buying or renting a house that had like 12 things in it, and then I added some more on for my own computations, and then I'll have to remember, what's the 13th one? Which one was the parent's interest rate? Which one was the bank interest rate? That I'm used to defining structs in C and giving a name to each thing. That was a little difficult, although I know nowadays with object-oriented APL you can also give names to things when you need to. And finally, the thing that I still don't understand is the axis operator. How I can take a multiplication and give it an axis, and then it fits in the right orientation and splits out, and I just have no idea. It's trial by error for every line of code sometimes. So, and for my background as I write code, I really enjoyed thinking about things in a new way, really visualizing the data instead of going iteratively step by step. But sometimes it was almost painful to write because I'm thinking, am I really going to make this, if I want to iterate over 1,000 things, am I really going to make like a vector of 1,000 when I know I don't need that? Like, it's this productivity versus efficiency concern that, based on my past experience, is very hard to let yourself go and just write it in the way that makes sense. The other thing is, I kept hearing about idioms, that you can do it in the straightforward, inefficient looking way, but underneath the scenes, the dialog or the APL compiler interpreter will actually do what you want the efficient way. And so I was like, do I need to do that? Do I have to learn all of them so I can write programs in a good way? Although I'm pretty sure I don't. But that was always in the back of my mind that maybe I need to know those things to write efficient code. And also copying by value. If I'm passing a gigantic matrix around, then what's going to happen? Do I have to worry about that as well? Should it be a global variable that everyone just reads from? I just didn't know. And the other thing, this is more important with my work rather than as I'm thinking of using APL outside of this context, is I'm always interfacing with things on the outside. How do I get my data in? If it just comes in as a big chunk of text, how do I get the values out of it, and then how do I save that back out? Because I use a lot of different programming languages. I use a lot of sources from outside, and I need to do further processing outside. And finally, when I'm just restricted to arrays, like, how do I do the things that I'm used to doing? Although pointers lead to a lot of trouble, I also don't know how to do things without pointers. If I have like cyclic structures like graphs that loop around, or trees that are recursive, like how do I store this in a array? Do I use nested arrays? I just didn't know. I was actually kind of surprised to see what people have done, and to see, how do you handle XML, which I think of this recursive tree structure. The Dialog APL and will give you in a matrix format in a way that will seem very interesting and very useful, and even in the context of the Windows Foundation. I forget the new GUI stuff that's in that Dialog was showing off, that actually you define your GUI in an XML format, and then from that you create the GUI. That was actually very straightforward to make the XML from this format that Quad XML supports. So I thought that was interesting. And also hearing for me, inspirational talk about writing a compiler in APL that compiles to C code. I don't even know how you would write a compiler in APL, so I'm very interested to learn more about that. So here's kind of very briefly what I thought of each of the main contest problems. The first one, which was very straightforward, was just kind of a surprise off the bat to say, wow, APL can do XML. I wouldn't even know. And the second thing, where it's really the model of buying or renting a house, compared to last year's problems, because I did actually play around with the contest last year, but I didn't enter. It seemed like very practical, like this is a real world, this is what people do with APL. But from an outsider, you look at it and you think, do I really want to do that on my free time? Like, is this what I'm doing at night when I'm back from school? But it helped me to learn a lot, and it was still difficult for me to learn to craft code in that way. And then this aggregate series that Mstislav went into a little more detail about, where you have this matrix and you're given like a specification of how to aggregate some of the values. I don't have my code in this presentation. I actually have very little code for the actual contest in here. But I did it in like a totally different way, where I like reshaped the matrix so that I could run like one function for each line with reduce, and then like reshaped it back, which to me was the way that I tried to imitate that interlace function that I like so much. That was the only time I feel like I did something like that. And the last two were more like getting into math that wasn't what they gave you. For the buy or rent, they very specifically defined exactly how you compute month by month with all the different model parameters, but here it became more open or open-ended. And the very last thing, when you had to optimize fast code, I really wasn't sure how to do that so well, so Mstislav beat me by far in that one, I'm pretty sure. I ended up trying to keep it somewhat readable, but I ended up just kind of unrolling the loops, but not doing too much with that. Because I'm still not sure exactly how APL, like what it takes to make APL fast. And so here's an example of one of the Rosetta problems that wasn't in the main competition, but was the extra, more mathy style problems. That out of, I think there were 5 available. I entered solutions for 3 of them, and I just got 1 of them. And then there was one other guy who swept all the other 4. But this is how I did the one that was apparently good. So the idea was, you have this sequence, we'll just say A, N, because A1, A2, A3, up to whatever, and you want to know what's the maximum value of A of N over N between these powers of 2. And so this was an example, because since I come from a kind of a functional background, for me, I sleep, eat, drink, D functions. It's like how I work. So I put lots of these together. I actually split this code on multiple lines. It was actually even uglier before. But so if I had the maximum, maximum takes a vector and returns the biggest thing in that vector. 2 is a dyadic function, which you put something on the left, something on the right, it gives you all the numbers in between. So if you say 3, 2, 7, you get 3, 4, 5, 6, 7. And the last thing does all of the work to solve that goal. That starts with the numbers 0 through 20, then applies 2 to the power of that, so you get 2 to the 0, 2 to the 1, 2 to the 2, up to 2 to the 20. And then this was one of my favorite things in APL. It's like n-wise reduce. That takes each of those 2 at a time, and then generates all the numbers in between. So you have 2 to the 0, you have like 1, 2, 2, 3, 4, 4 through 8, 8 through 16 in each of these lists. And then for each of those lists, calculates A of n over n and returns the maximum. And with this tiny, tiny little bit of code, solves that problem. And apparently, according to the Dialog website, this was the fastest solution for this problem. And I thought, it's so clear, I didn't have to contrive in some optimized way, how am I going to loop through this or loop through that and not compute this too many times.
that it has worked and it's really clear. So that's for me the main strength of APL. And so when it comes to the contest itself, I would have to say I thought it was a great idea because I never, ever really would have learned about APL otherwise. Since now I'm in grad school, I have a family, I don't really spend the time exploring programming languages like I used to. It really took something like this to kind of poke me and get me started. And one of the things that's very difficult, like last year I heard that the math problems, the people who really want to solve math problems quickly aren't necessarily the same type of people that will be using APL in a normal job. But this year, with the more practical problem, at the same time it's not as interesting, so it doesn't attract as many people. So it's very difficult to design new problems. And I'm hoping to contribute some ideas there as well in the future. So I want to talk a little bit about what I do and give an example of a problem that I think APL solves really well. Basically my focus, I'm a PhD in computer science, PhD candidate, and I do bioinformatics. And bioinformatics is strange because it's a field that, unlike the other areas of computer science where people, specialize in kind of a methodology or type of algorithm, bioinformatics is just, you specialize in the people that you talk to. You know how to talk to biologists, and they expect you to know how to solve every type of problem imaginable. And so 3 of my focuses that I've worked on, and will somehow contribute to my thesis eventually if I ever graduate, are information retrieval, where you have like a lot of text and you want to find the text that's relevant to you. Sequence analysis, where I have DNA sequences, often like gigabytes of sequence, and you need to do stuff with it. And disease association, which is a fascinating new field where people try to determine the genetic causes of disease. But one very simple specific problem that's in the sequence analysis group is if you have a bunch of sequences that are similar and you want to find more that are like them, how do you do that? Like if you have these 3 sequences they're all similar, they only differ by like 1 or 2 letters, how do you find more like them that aren't necessarily exactly the same as those? I'm not going to go into the details of this, but you form this position weight matrix that says for each base what's acceptable at that base, but it's never like yes or no, it's more probabilities and scores. And so the first step is you want to count for each of those columns, how many did you find? Like for the first column, 2 were T and 1 was G. So that's how this shows up. The second column, all 3 are C. So you just have a 3 in the C row, and so on to the end. And so you say, how can you generate a matrix like this in APL? And of course the answer is one line, which is beautiful. It's that you do an outer product between the letters and your matrix, sum up over each column, and you're done. And then to actually go from there to what people actually use in practice, where you smooth out the counts, you normalize them to probabilities, you calculate log odds with respect to background probabilities, all these complex things are each like one line of really simple code in APL, which is amazing. And the result from those 4 lines of code will give you exactly what people use in practice. And then how do you use that matrix? Where you have for each column, you have the score if you solve each letter A, T, C, or G, and you need to add them up. How do you use that? It's also one clear line that uses something that I didn't know if I would ever use, the dyadic transpose, where you extract the diagonal. I never thought I would use that, so I thought that was pretty cool too. It took me forever to figure that out. And one other thing, this is something that my advisor works on, that I'm starting to get into it, that they have this complex algorithm where you take unions of graphs and you sum up the edges that are common and all these things. And basically in APL it ends up being very simple with a D function. The goal is not for you to understand this, but just the lines are very short and very simple. There's nothing complex going on, and you compute exactly that function in the previous slide. And you can even generalize it just by taking what was like the graph. You apply graph to a scalar. You can just say, if there's a list of vector, apply graph to each of them and union it together, and poof, you have this generalization without writing a whole extra like loop around it or figuring out how to take the union of graphs. It's really nice. And so my final thoughts are that clearly from this conference, APLers are very excited about APL, and APL is definitely something that's actually worth the excitement. But really outside, no one has any clue that this is going on. And so
the APL community needs to reach out and make it easy for others to join in. And I think this contest is one way of doing it. But as we were talking earlier, the contest kind of reaches out to computer science people. Those are the people who want to enter programming contests. But how do you get to the non-programmers, which are the people that can really benefit from APL? It's a whole other thing. And maybe going to these conferences of these other people who could benefit from APL is one of the major ways to do that. So I conclude by saying that APL is beautiful, that you can easily implement elegant algorithms, that it's a whole new paradigm of thinking about problems that's definitely going to affect the way that I work now. And I would not have discovered any of this without the contest. So, thank you.
Yeah, any questions for Ryan?
Why don't you go back 2 or 3 slides to the, go a little more. One more. One more. Let me ask you this. Had you not known APL, had you not known of APL, how and what would have you used to solve this problem?
A lot of loops. Yeah, I mean, I guess one of the main things is that it's never a question of what's possible in this language versus that language. That I'm solving things that I could have solved in the other languages as well, and because I've been using them for years, I know exactly how to do it. But there's something different about doing it in APL.
I guess the question is, what would have been your second technology of choice, supposing that APL were not amongst the things you could use?
Generally, just because of pragmatics, I use Java at school. Just because I write code that has to run on a lot of different machines. If it's something that I need to get done quickly, I might write it in. There's kind of the 3 tiers. It's like, how much time do I have to do this, and how fast does it need to be? For me, in the past, it's been, if speed really doesn't matter, it needs to be done quickly, Python. If I have more time, it needs to be more engineered, and speed is important but not critical, then I do Java. And if it's absolutely critical, if I'm going to be processing gigabytes of data, I need to be done quick, but I have more time to implement it, I do it in C.
Just 2 comments. First of all, both of you have some very nice appreciation of expression in the language, writing clear, succinct, maintainable code. Both a compliment on that. But on your question about compilers, I mean, there's no need to be afraid of compilers. A compiler is just a piece of code that reads a character vector and produces a character vector that's a little different. So anybody can write a compiler. It's just that, there's things you might want to do in between.
Yeah, I think it's just, there's so many data structures involved to do a good compiler that I have no idea how to do, like just trees and data flow analysis. And
I make it work, and then you make it work fast after that.
But there's not a lot of data to analyze.
and
Apart from wanting to borrow money from you if you won, what would you say was the most interesting reaction of your colleagues to you doing?
So they didn't know until I won, and they were like, well. Then my first response, my professor said, "Isn't that the language that Dijkstra said was like a mistake carried through to perfection?" And then he realized it's actually PL1, not APL. And he realized, I have no idea what APL is. So most people just had no clue. They didn't even really have a reaction like, what's APL? So that kind of shows how little people know about this.
It will stay with me.
Yeah.